Hey, what's up? Okay. It's bullshit. It should be void. We can return a shared pointer to void. Mm, this is also bullshit. Feeling good. That's great, Will. Feeling good. Let's see if this builds. It doesn't. Surprise, surprise. Because we cannot convert value of type bridge func void, aka native callback to expected type std function. Oh shit, yeah, that's true. Um, shit, that's not good. Okay. So I think the issue is that we are trying to so I created a new type for JS callbacks and it's called callback. And this is not an std function, but something completely different with methods like call sync, call async, and forget, and a call operator. But the problem is that we have one case where we need an std function, which I'm trying to migrate away from right now. But we need it here for the promise. So the question now is, do we want to create a function for this, an std function, or are we okay with not doing that? Add unresolved listener. Actually, let me open the zero problems. Oh, there we go. So it's in here. Yeah, this has to be a function, which is how it works. So it's a vector of unresolved func, which is an std function. Gives us the result and an error. And we're trying to pass a callback now to this promise, but it expects a std function, not a callback. I don't think I want to do Avidia. What's good? I don't think I want to pass a callback here. Let's see. We can, so I'm writing a code generator here, and I'm generating this piece of code right now, which can wrap a C++ function in a wrapper. Actually, I don't think we need this anymore, but we need this one. So this is actually this can take a void pointer for a closure holder, so a reference to some Swift class, a void pointer to call a C-style function with arguments, and pass in the closure holder from the previous step here. So this is a common trick you can use to bridge std functions, or I guess lambdas or callbacks from one language to another by just using C-style functions. But C-style functions have to be static and cannot capture any state. So Um, as an example, let's see where the function is. So here, for example, we have a Swift lambda that captures state inside, and it captures the promise. You know, this is a value from outside, so it captures this inside the lambda. So it's no longer a simple C function. We kind of just pass this around to some C APIs. We need to capture the captures, the values that we capture here in a void pointer. So what we do now is we create a closure holder, which actually holds the Swift closure, and convert this to a void pointer by making it unmanaged. So unmanaged pass retained closure holder to opaque. So now we have a void pointer of this closure state. We can pass this void pointer to our C function. Then we pass along a call function that just receives the state, unwraps it again, and then calls it. So this goes in here and calls it. And we pass a cleanup function to destroy all of this again. So this is the common way to convert a lambda with state to a C-style function. Pass the state, pass the callback or the call function, which is static and takes the state, and then pass a function that destroys the state. Simple as that. The problem now is that we're no longer using SCD function, or I want to migrate away from it. So this is not what gets generated anymore. So right now we have a callback here instead of a function, and I'm trying to pass that to the promise. How do I do that? I can just generate this code right here differently, I guess. I can. So maybe I can just rename this. Create cx function Swift helper. It's going to be callback Swift helper. Perfect. And now I'm going to do the same thing for a like visualization can be used from Swift. This is no longer called wait, where's the func underscore coming from? Um anyways. This is for SCD function and this is for callback. Okay. And the difference is going to be that we have a shit. This is still a callback. Um this is not easy. God damn. This is not easy shit. Simple as that. Mark while writing a masterpiece. Thanks, Tom. Yeah, it's not a it's a pretty funny trick if you're talking about the lambda part. Because that's I think how you can easily bridge any callback between languages that have C interrupt. So I think it's very convenient. And I think I can show you the part on the oh yeah, this is the part on the C++ side. You receive void pointer, you receive a call function and a destroy function. And then you can do whatever you want with it. So in my case, I'm creating a shared pointer. So the destroy function is called automatically when I'm no longer using the SCD function. And then I'm just using call and passing the context in. So it's completely memory safe. It captures the entire state, and I think it's very low overhead, to be honest. Okay, I'm still not sure how to actually tackle this, to be honest. Mm, So I guess it's no longer function type, this needs to be callback type, and then we switch was hearing the React Universe podcast yesterday before sleep. I remember you mentioned a closure hack. Yeah. Yeah. The closure hack is pretty fun. In Swift, you also have to do something else. For some reason, STD function, I mean, right now it's no longer STD function, it's native callback, but STD function cannot be copied or captured by value in Swift. So what I do instead is I move it, or actually not move, but copy it into a shared pointer here. And then not sure if I have the code for that somewhere. Let's see. So basically I just share it. Yeah, there we go. Instead of just passing an unfinished here into the closure directly and calling it, I have to, for some reason, share it to a shared pointer and then access it through pointy, dereference it. So it doesn't copy the function itself, but only a map, just increment the ref count on it if this lambda gets copied. I guess it's just how Swift functions work. But yeah, otherwise it would just copy the function too often. Okay, I got sidetracked again. Let's see. So am I going to do a huge refactor for this, or am I not going to do that? I can probably also just... Yeah, no, never mind. I need this. I can try to... It's not as easy as it looks like. Whatever, let's just try it. So type dot parameters dot map, and then we do let's call it func parameters. We don't need name info. And then we have the return type as well. Func return type. We get it in C++. And then we have actual type is std function return type params. Are they joined? Yeah, they're joined already. Okay, so this is the actual type. And then we have the signature for the parameters, and then the bridged. We don't need the bridge type. We just need the return bridge. This is not bridged, okay, but we probably need this forward as well, and then shared closure forward, this forward. Specialization name, I don't know if we need this, to be honest. Probably not. Wait, where's this going? No, I don't think we need this, to be honest. So we don't need this. We only need actual type, create name, maybe, okay. Wait, what is it? Specialization name? Whatever, I'll just... lost track, okay, escape. CPP name. Hey, Lois. Actual type, escape that shit. We don't need share anymore. We got the return type here. Okay, we don't need to call it like this. Cool. Okay. And then, yeah, maybe actually we also need the bridge type. Okay, perfect. And now I'm just gonna move it in here. Run codegen again. Oh shit, added and removed. Okay, no, I think it's fine. Now the code that got generated is a little bit different. No, this is the same. Callback is still the same. Wait, what? Ah, yeah, okay. So This also kind of needs to be renamed, I think. Create. Maybe it needs to be renamed, to be honest. Name is probably, yeah, fuck. Specialization name. There we go. Okay, run code gen. And now well, actually, we also probably need to, in promise, we also need to do a different callback conversion, because here we're, yeah, that's a resolver. And then we are with bridge type. Yeah, I think this is a callback again. Function. Shit, okay, this is a callback again. This will not work. Fucking, okay, it's still the same problem because we are not using, if I just change this, it will work. So if I just change it to create callback void double, I'm just going to use create func void double. Probably works, I don't know. Callback void std exception. I need to, okay, specify the type as well. So, for Rust bindings to C, C++ for Iron, would you recommend Rust CXX rate or just directly using unsafe C functions and then writing ones? To be honest, I haven't really worked with Rust yet, so I can't really answer that question. I think at the end of the day, if there's a tool for creating C++ bindings, that would definitely be a huge help because everything is in C++. Um, we need to actually specialize the template here because a C++ template cannot be used in Swift. So what I do is instead I give it a name using std shared pointer promise car equals and then just the actual type. So now we can type it out in Swift because you cannot type templates out in Swift because templates don't exist in runtime code. It's all just compile time stuff, so you can't really type them out. Anyways, so this is func create func and then shit, it doesn't work. Why not? Fuck you. Oh, it's not called func. It's actually called callback here. Okay, I'm gonna do something just to test it. Func. Oh, sorry, other way around. Okay, so I think now we should have func void car. There we go. Okay, so we have func void car. Yeah. And then here we should be able to have func now instead of callback. Fuck. Create func void std exception. Func void car. Func void car. Great. Func void double. Func void double. And then func. Func. Okay. Let's see if this builds. Probably not because I'm still missing a lot of things. It does not. Okay. Why not? Callback std void exception. Oh, we still have one more case. Func. Func. I think I renamed the headers as well, so I'm not sure if those are even there. Let's see. Return type is an abstract class. Where is that coming from? Ah, shit, we cannot return an abstract class here. Plus callback. Okay, so this needs to be JS callback. And then this needs to be, yeah, this is fine. Yeah, I think this is fine. Does it work? JS callback. Yeah, this should work, right? Shared function. Oh shit. This should be moved, not copied. Let's see if it still works. No, it doesn't. So we need to move this here. Hey. Hello, hello. And then no matching variable has incomplete type void. Shit, we have some void typing here as well. Okay, yeah, this also doesn't work because so we need to, if you write templates in C++, you can do a lot of really cool compile time shit. So for example, here we have a signature, and then the template is only fulfilled if you are passing in any kind of function template. So it needs to be a return type, and then the arguments here, which are is a parameter pack, and then we can actually, return type can be void. So here, if it replaces t return with void, result would be an incomplete type. So we need to check if, and we do a const expression check. So this runs at compile time. If is void, scope value, t return. Just move this in here. And if it's void, we just call it and resolve the promise without any results. So this runs at compile time and just removes the branch that isn't fulfilled by this compile time check. So this is just a type template. I don't know what it's called. And then we still have a few more issues. We have, okay, there's some construct add, so there, maybe something cannot be fulfilled, but maybe some template or something cannot be fulfilled. Let's see. JS callback requested here. Maybe return JS call. Okay, is the constructor correct? Dispatcher function name. We have a runtime as a pointer. Shared function is moved. Dispatcher is a shared pointer, and the function name is a string. Okay, something cannot be created. Let's see. Allocate shared. std make shared callable. Wait, first of all, what is this? Failed to call. Oh, okay, shit, this is stupid. This should be get name dot c string. And then here, same story. %s get name c string. Oh shit, actually, no, this, I'm lying, sorry. Do we have a logger call somewhere as well? Log. Okay, that's it. And then, yeah, maybe we need a constructor for this. I hope not, but maybe we do. Wait, where do we actually initialize that? Here, okay, runtime, move the function in thread ID, thread name, function name. Is that correct? Runtime, move the function in. I don't know if we should move that, to be honest. Let me just call label and then do the same thing here. Maybe I just copy this over. Let's see. Okay, this one. Copy it over. Initialize it. Runtime. Function. Move the function in. I'll move it around because if we copy this around, it would be unnecessary copies. And each copy of a reference type, so in this case, owning reference, which is a reference type I wrote myself, but it's the same story as a shared pointer. If you copy shared pointers around, they do mutex locking and It's just unnecessary if you don't need a copy. So in this case, we just move it around, which is what this double ampersand operator does. And then you need std move to forward the move. So dispatcher, this is a little bit different because we cannot move references to the dispatcher here, because we're just getting a reference and holding on to it for longer. And then, wait, what else was it? Original thread ID is, let's see, this thread. Come on, get ID. And then function name is thread details get. Sorry, not function name, dude. Am I stupid? Function name. Original thread name. Thread utils get thread name. Perfect. And then we only do this in debug because in release we want to make it faster. So what I'm doing in release is I'm not doing the thread checks. Then it's just gonna be dispatcher. It's just gonna be no, sorry, not dispatcher. Wait, what am I doing? Dispatcher is not part of this. So dispatcher gone. Okay. Then it's gonna be runtime function, this and that, and then here we also have function name, runtime function name. Perfect. And now we should be able to construct this, I think. I'm not sure. Let's see, callable. I think so. Why not? It's still the same error. Imagine. Okay. Okay, so it's saying we cannot construct callable. So what I'm doing now is I'm just going to, is it private? No, it's public. So what I'm doing now is to, was the constructor private? No. Oh, the constructor is private. That's maybe why. So constructor is public. Maybe std make share does not have access to the constructor, or maybe it's just confused because of the templates, because this is the templated class, and we have a nested subtype in here, which uses those templates. So what I'm going to do to kind of simplify this is to just try to do auto callable equals new callable, to just explicitly call the constructor and then just see where it breaks. And then move this away and just see if this works. Oh wait, I removed those, right? So it should be like this. Maybe that's why. Not sure if it. Come on, build. So I'm still not sure about how to build fields. No viable conversion from const callback. Oh yeah, it's the same story now. We have a wait, what? Callback to native callback. So unfinished. Okay, we're getting there. Unfinished is a callback, and save to file is taking a native callback. Okay. Okay, this makes things a bit harder now. Yeah, this is not easy. I need to make this a callback, but then I cannot really construct this, I think, here. So what's the answer? Do I even need this wrapper? To be honest, I'm not sure. I don't think I need this wrapper, to be honest. Uh, Not a good idea to remove a lot of code right now, but let's just try it. So the actual type should be the normal callback. And here we return the native callback. And then I don't think we need to share underscore something. Also don't think we need the wrapper. Also don't think we need to move forward the parameters here. Uh-oh. Okay. So I also don't think we need that, to be honest. But we'll see if that was stupid to remove. Shared closure. We don't need a shared closure. We just call it directly. What's it called? CPP parameter name. Don't need the bridge. Don't need this. Don't need that. Okay, and now what was it called here? Underscore wrapper. Okay, I'm also not using the wrapper anywhere. Huh. Let's just run it and see what happens. Okay. So it got a lot simpler. We now have the specialization is callback. We create a callback. Yeah, okay, shit. Abstract class. So this needs to be a native callback. Okay. This needs to be native callback. This needs to be native callback. Come on, where are you? This needs to be native callback. Run it again. Okay, so this is native callback now. And then let's just try and see what happens. So we create a callback. Oh, this is still the wrong code to replace it again, but okay. Can I just put this in the code gen? Okay, where's the promise code gen? We have, yeah, this is the on resolve on reject. Let's see. Quick and dirty, but it will work. Okay, let's just do this. Run the code gen. It ran perfect. And now we have func void SC exception here, which is exactly what we want because we created it, I think. Func void. Yeah, okay, we have that. Perfect. But now we are still create callback. Ah, sorry, replace all. Why is no one saying that? We need replace all. Okay, func void SC exception. Perfect. And now we can attach the listeners, hopefully. If this doesn't return red, then that's fixed. Okay, build failed. Nice. Has no member call. Yeah, okay, that's I think intended because it should be on finish dot call as function. There we go. Can we pass it like this as well? Yeah, this works. Nice. So we don't need dot call anymore. We just need, oh shit, this, it failed again. Now we have has no member call. Oh yeah, we're still doing dot call here. So rerun the code gen with the fixed call code. And now what's happening? I didn't even test my mic. Can you guys even hear me? A viable conversion from switch part call callback. Okay, this is a callback. Shit, yeah, okay, so this is a callback void. Wait, what? Oh, it needs to be a native callback. Yeah. Okay, perfect. Uh, 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 uh. This won't work. It cannot be a native callback. It has to be some kind of. It has to be some kind of. Why can I allocate a static or abstract class? Why does this not work? Return type is an abstract class. Yeah, okay. I get it. It's very inconvenient, but I get it. So maybe we need. Okay. Okay, yeah. We so we cannot allocate a stat a pure virtual class, a pure abstract class, so a class that has not any, it doesn't have any implementations for those methods. It's all zero. So we cannot just make this callback, but we can create an additional type called callback, and then this is native callback. This is the concrete type. We can use this, and this is just a type we use for incoming arguments, but not for actually creating it because we cannot create an abstract class. So what we do now is this is the callback helper, and then we have native something, native something, and this is not native. Perfect. Run CodeGen, and we have native callback void, and we have callback void, and oh shit. Oh, it's yeah. I forgot to also switch that. Obviously, why is no one saying anything about that? So we have yeah, we switch it around. This is incoming. We create this. Run CodeGen again. Come on, guys, I need your help to focus. I do this all alone. Oh no, virtual functions cannot be called in Swift. Yeah, well, this is a compiler limitation, and this sucks. Okay, but it's probably only because it's purely virtual. What I can do theoretically is to just make it throw. And then we have character is not implemented, get name is not implemented, this is not implemented, this is not implemented, and call sync is not implemented. Maybe it works now. I don't know. I have no idea. Let's see. Oh, code failed. This is called callback now. I need to replace all of this. Hydrate test object. There we go. SCD function. And this is all going to be callback. And then same here. Also replace it. Okay, if it's failing here, I think Nitro modules itself already compiled. Callback dot callback dot call async. Call async, yeah. And this is going to be a promise. Promise of a SCD string. then promise not then, not promise add on resolved listener. Once we can call async and forget with results. There we go. SCD promise, SCD future. Wait, what? How is the return type a? Oh shit, this should not be SCD future. Yeah, we don't have enable new promise. Don't care, don't care. New promise type. Yeah, for function type, we can now use new promise type as well because we have been using SCD future all the time. So this should be replaced with promise now. Let's see. SCD future. We still have 2 cases of that. So replace that. Do the same here. And then now we should be able to get a wait, what? Promise. Oh, never mind. This should also be okay. God damn. God damn. Okay. Just to keep it simple now, I think I just messed up somewhere and for some reason, where it comes down to new promise. It's a nested promise right now. So I think I don't know where I messed up, but I don't know, for some reason it's just a nested promise right now. Actually, now we can do this. And then call. No. Okay. Wait, what is this even returning? It's a shared pointer of a promise of t return. Well, I can just uh, hmm, we do this return type else new promise type. It's the return type. So now what we need to do is type don't get code language. Now we yeah. So we need to wrap it like this. If we generate the code, it should be callback dot call async. Yeah, it's no longer a to replace it as well. So the callback of promise double is now just a double. And the callback of promise string is now just a callback of a string. And the same story here. Callback double is gone. It's no longer promise here as well. Okay. And now if we do call async, yeah, it's a promise of a string. Nice. So if we do promise add on resolved, wait, what? Yeah, no, that's fine. Yeah. Mr. Snowfox, hello, hello. Okay, so we still use it wrong here. We're doing set value from JS callback and wait. So what am I? Wait, set value dot call async. This should be fine. So we can just await a promise, uh, which is pretty helpful because it just returns a STD future. And STD future is very easy or very convenient to use in C++. You just are not allowed to copy it. You can move it around, but if you do, if the destructor runs, so if it's leaving the scope here, it will block. So you need to move it to an asynchronous context, but we're already inside an asynchronous context here, so it's fine. It's fine to block. Um, anyways, let's see if this builds now. Mm, nice, it built. Oh my God. Okay, now I need to clean this up somehow. We got a lot of changes. Look at this. So we have this hack that I need to clean, where callback and func are two different things, even though they are technically, no, they're not, they're conceptually the same thing, but they're not implemented the same way because a JS function that you pass to native to Nitro is technically not an STD function. It is a callback. So it is a separate type because STD function would be just too much overhead, and a callback is just much simpler in memory. So it's about efficiency, and also it's more powerful because I don't think I even mentioned what I'm working on right now. I'm working on synchronous callbacks for Nitro. We need this for vision camera frame processors, for filament rendering, and all those kinds of things. By the way, it started and the tests do not run. Something happened. Where? Callback void vector. It's a callback from JSI. I know where it is. It's in callback and it's in, I bet it's in here, to be honest. It's probably in here. I don't know why I cannot get the property name. It does not have a name. Maybe it's undefined. That's why. Okay. No, I don't think name can be undefined. I don't think. Does it say so in the spec? Anonymous or empty string. So it cannot be undefined. Must be something else then. Um, no, it's something else. Oops. Okay, so what is it? Invoke async. Callable call. How is it failing in here? Callable call. Why is it failing in here? Runtime is null pointer. How can runtime be null pointer? Oh, dude, I forgot to remove this code here. Oh, shit. Fucking hell, stupid. Okay. Um, yeah, okay. Um, I'm working on synchronous callbacks, so you can actually receive a function in a Nitro module. Hybrid test object Swift. So you can receive a callback. Do we have any callbacks here? Maybe. Mm, there we go. So you can receive a callback here and have it be fully synchronous in a sense that there's no runtime scheduling involved. So you can just call the callback and it instantly calls the JS function. And only once the JS function completes running, it goes to the next step in native code. Um, so it's quite performant because it's the same thing as essentially just calling a JSI function directly. There's no threading involved, and you can get results back instantly. Like if there's a double or something as a return type, you can get it back immediately. This is helpful for example, in Vision Camera because we need to run the frame processor synchronously, and once it's done, we can delete the frame. Or in Filament, where we render the scene, and then once the rendering completed, we flush it and send it to the GPU. So synchronous rendering is really important. Sorry, synchronous callbacks are really important. And then maybe potentially we can also extend it to synchronous rendering, or it would allow synchronous rendering for stuff like wishlist or I don't know, fabric synchronous rendering, stuff like that. It's synchronous layouting, for example, and worklets. There's a lot you can do with it, but it needs to be a quite flexible type because we need to specify whether this callback is going to be called synchronously or asynchronously. The reason being that we cannot just keep an instance of this callback in memory and call it whenever we want, because it needs to be called on the JS thread. We cannot just call it on a background thread because that would crash because the JS runtime is not multi-threaded. So you need to be able to jump back to the JS thread to call first on the proper thread, which most modules don't need. But again, Filament and Vision Camera, they have their own dedicated rendering thread, and then you call it on there. Okay, let's see if all the test runs now. If all the tests run now. It's still crashing. Where is it crashing? I think it's actually still, I think that was a bug. Hold on. I don't know, maybe name is actually undefined. I don't think it should be. Uh, So synchronous callbacks are pretty powerful, but it's quite complex because a callback, as you can see in the callback implementation over here, can be called either synchronously, so directly call it and get the return type, or asynchronously, so call it, schedule the call on the JS thread, and then return a promise that resolves to the return type once it has been executed. Or called async and just forget the results. So no promise creation, no allocation is being performed. It's much more performant than this one. If you don't need to await the result of the callback, just use this. You just schedule the call and it just runs. This is the default behavior of callbacks. And then also you have this default operator. If you just call it, it returns either void, so shoot and forget, um, if it is a void return type, or if it has any type of return, then it returns a promise and is awaitable. But if it's just void, you don't need to await void. So this is how a callback works. This is actually how a JS callback works. And then a native function is obviously different because there's no such thing as it being sync or async, because you can just do that in native code. It's just way easier to just use threading or dispatch queues. What is the normal RAM usage for a React Native app, if at all there is any? I don't know, maybe less than a gigabyte. um, I don't know how much normal would be, but it's definitely like around maybe 300 megabytes. I don't know. Okay, so the tests are for some reason not running. There's something being, I broke something. I don't know what I broke. Uh, Maybe the callbacks are not resolving. I don't know. Um, yeah, this is interesting. Why is this not working? wonder which test does not work. Let's start again. Okay, so all of those work. Where's the callback tests? This one works. Async. This one works. Callback. Running. Okay, it will not. It will just never callback. Let's see. So we pass a callback in here. We receive it here and we call it. The problem is that yeah, we receive a callback in here. What am I doing here? This is a lambda that returns a lambda. And then in here is a lambda that returns a lambda. And we call it immediately, so it just returns the lambda. What? Anyways, gonna fix that later. Callback. Oops, this is something else. Okay, so callback is for some reason never called. Why not? Why isn't it possible? Why not? Let's just see what happens. Okay, so let's walk up the tree. Okay, so if we step into this now, call async and forget, run async. Callback. JS callback. I don't think I can put a breakpoint here, to be honest, but we are in call async and forget. Callable is being copied in here. It is should be called. Yeah, I don't think this breakpoint can hit. Well, that's annoying. Maybe this. Yeah, just put some logs in here. Callback being called. So the thing is, because this is a header and a template, I cannot put breakpoints in here for some reason. I don't know. Render okay. And then function is locked. Func is dead. And then here, calling void and calling. Let's see what happens. You may not like it, but this is the ideal way to debug. We don't use breakpoints around here. That's the annoying thing about C++ generics or templates, because there's no, like, you don't even have IntelliSense anymore in here, most of the cases, because it's just a compile time template. There's no way. Okay, let's see what happens. Being called thread is okay. Function is locked. Function is locked, but for some reason, call just never happens. Maybe this is throwing. No, actually, this should call calling void or calling t. Wait, what? Being called thread is okay. Function is locked. This is a check that's running. Oh shit. Uh, So what if this here is locking, this mutex and owning reference? How can it even lock, to be honest? This is, maybe if we make this a recursive mutex, and then in borrowing reference, we also need a recursive mutex. Let's see what happens now. Oh yeah, here we have a new recursive mutex. So maybe, I don't know why, but maybe there's another owning reference being locked for some reason. Why is it locked? Why is it locked? How can it be locked? How can it be locked? Holy shit, I missed 1 hour of streaming. Don't worry, it wasn't that interesting. Okay, let's see if this runs now. Remove this breakpoint. We don't like breakpoints around here. Okay, I can't even remove the breakpoint. Holy shit, oh, whatever. There we go. Okay, it's now working with the recursive mutex, but expected test if there are not any errors. Error, SCD exception. Okay, apparently, okay, we can ignore this one, but apparently there's something going on with callbacks still, because for some reason this is throwing, and I don't know why. And I don't know why there's no error message actually. Why is there no error message? Error STD exception. Um, Wait, what? Please remove this breakpoint now. Thank you. Maybe, I don't know, maybe there's something broken. Okay, so now it failed on 2 tests. Get value from JS callback and yeah, okay. So it does expected test and not there any errors, STD exception. So maybe there is some error when we actually call the callback. I don't know what it is, but let's just try to do it. Call async from exception is let's just try that. I guess the JS callback is throwing somewhere. Call async. Promise create, this must work. I'm sure this works. Return. Move the result in here. I called it test. What? Huh? We need to downcast it. Uh, okay, we'll fix that later. What am I doing wrong? There we go. Const cast. Okay. Beautiful. Great to watch you fix here. It's just live. Many are the times you see the results you produce and think you're always making things work. I pain. I'm glad I make. Yeah, it's a lot of pain to do C++, unfortunately. Okay, where's... Wait, what? STD exception. Why is there no error message? Am I bundling STL live? STL two times? I don't think I'm. Okay, so this is probably correct. The problem is, for some reason... Okay, I think I know a way to hybrid function to get the error message at least. And that's probably to remove this block here. Um, do we have any catch-all blocks anywhere? Ah, okay. Yeah, I'm just gonna ignore that. So I think those are just minor issues that maybe take a few hours to fix, but the main problem right now is how do I design the API? Because I still need functions, but I only need functions in a private code base to bridge from Swift to C++. I don't need functions for anything. Actually, I do need functions as well. If you have, there's one use case where you can expose a native function as a JS callback. There's still no error message. Maybe in here we also need to remove it. There's no option to sponsor, but thank you for asking. I don't think I want to monetize this stream. It's just a still way to kind of look into some issues. Um, so, but thank you. Appreciate that, Rodrigo. Um, so I need to have two different types. One is a JS callback and one is a actual native function. Actually, I could use the native callback structure for that. Native callback must be very simple though, because I don't want to abstract on top of std function. I would love to abstract on top of actually, that's the perfect point to avoid std function now. This is amazing. I can actually create a... Holy shit, this is really cool. I can avoid std function entirely because std function is very heavy. If you have never used C++, std function is a pretty heavy type. And I'm currently, the thing I showed before, I think this was before you were here, Rodrigo, the way to bridge a Swift Lambda to C++ is pretty interesting because I capture like all of the captured state of the Lambda is captured in one pointer, make it a void pointer, pass it, increment the ref count by one, unbalanced, pass it to native C, then also pass a call function along, which can unwrap this pointer and call actually the actual lambda with state on it, and then also a destroy function to clean it up again and delete the unbalanced incremented ref count. So those are the three things you need to expose a lambda to any language. And right now, what I'm doing is I'm throwing all of this into a std function and just passing that around in C++. But we don't need a std function for that, I think. Um, I think we might still need it, to be honest. I don't know. I'll figure it out later. Um, yeah. So we have a lot of changes right now. I think I'm going to call it quits for today, to be honest, because I want to play some Black Ops 6 and it's almost 9 p.m. but I have a lot of changes and I kind of want to simplify that. Yeah, okay, this is gonna be very, very messy. Anyways, just gonna leave it at that for now. Um, for some reason, messages are not propagated forwards. I don't know why this is happening. I don't think I did anything that might have broken this, to be honest. I don't know. Hmm. So I should probably fix this first to kind of get the error message again. So SCD exception can properly um, work and actually show an error message in JS. But anyways, thank you guys for watching. I'm gonna do probably another stream maybe tomorrow or sometimes next week. I don't know. I'm gonna fix this and then callback or synchronous callbacks are going to be the last thing in Nitro or the last big thing in Nitro. I would call it feature complete right now, but for us to use it in Filament, we want to have callbacks in Nitro. Because right now we just use the unsafe escape hatch from Nitro, where we just get an JSI function and just call that. But we want to avoid JSI entirely in Filament. So that's why synchronous callbacks is something that we need. Same for vision camera. I don't want to use JSI in there. So for that, I need sync callbacks as well. It's a niche feature, but it's probably a very complex one, apparently. Um, anyways, yeah. Thanks for watching, guys.